In the previous video, you guys saw the derivation as to what is going to be the relation between the length, the wavelength and the frequency, correct? You also understood where the nodes are present and where the antinodes are present. Like suppose say if we consider the first harmonic or the fundamental frequency. See, what do we have there? You have the first node, you have the second node, and this is going to be the wave. Correct? There are two nodes, one here, and there's going to be one antinode in between. Suppose if you take the second harmonic, then in the second harmonic you have one full wave like this, and in the second part, the second one, it's going to go like this. Here there are three nodes, so 1, 2, 3, and there are two antinodes here and here. This is one antinode, this is one more antinode. Suppose if you do for the third harmonic, then we're going to have, so this is one full wave and you're going to have one more half. That means here this is one, and this is one more. There are 1, 2, 3, 4. 4 nodes, and there are 1, 2, 3. There are 3 antinodes. One thing is for sure, if there are n number of nodes, then there are n minus 1 number of antinodes. Or the other way around. In the sense, if you have n number of antinodes, then n plus 1 number of nodes. Correct? But let's try to understand the relation between the frequency, that is the harmonic, and the number of nodes and antinodes. See, in the first one, the frequency is F1, the fundamental frequency. And in this, you have 2 nodes, 1 antinode. And when you have the second harmonic, in the second harmonic, there are 3 nodes, there are 2 antinodes. And if you look at the next one, whatever the frequency we have, the number of nodes is going to be 1 more than that, correct? Always the case. Suppose if you take the nth harmonic, so what do we have in nth harmonic? What are you going to have? So there will be n plus 1 number of nodes, and that's going to be n number of antinodes. Make sense? Now the position of the nodes is very, very important. Let's consider third harmonic. See, for the third harmonic, what do we have? So you have 1, 2 and 3. There are 3 waves like this. And the below part also. If you take the below part, here you are going to have 1, 2 and 3. So it's going to be something like this, isn't it? And how many nodes are there? 1, 2, 3, 4. So first one, second, third, fourth. Okay. Now the position of the nodes are more important here rather than the number of nodes. From here to here, the length is L, correct? And L, so 1, 2, 3, 4. L has been divided into how many parts? 4 parts. But then let's look at the position here. See, from first part, that is from here to here, we have lambda, isn't it? That is the one full wavelength. And whatever we are looking at, this is the first node, second node, third node, fourth node. The first node is at x is equal to 0, well and good. This is the position of the first node. The second node is exactly in between that lambda, isn't it? Half of the lambda. That means its position becomes lambda by 2. So here, the second one, so let's call this as x1. x2 is basically at lambda by 2. x3 is at lambda. And x4 is at 1.5 times lambda, isn't it? Which is going to be 3 lambda divided by 2. That means in general what you will have, you're going to keep everything in terms of the value of lambda, correct? And now let's apply the same formula and let's generalize it. If you generalize it, then the position of the nodes will start from, so first is going to be x is equal to 0, or in the next case it's going to be L divided by N. Okay, and the next one it's going to be 2L divided by N, 3L divided by N, so on and so forth till L. Now how we get the formula? Remember the relation between lambda value and L value? This is how we are going to get it. Lambda value is equal to 2L by N, right? So if you use that, we are going to get this particular formula. Fair enough? That means, okay, let's solve this one for the first case, which is x2, lambda by 2. See, when you do that for x2 is lambda by 2, correct? Or in the next case, lambda value is what? 2L divided by N, correct? And in this case, N value is 3. That means lambda is equal to 2L divided by 3. Substitute that, x2 is equal to lambda, which is 2L by 3 into 2. So 2 2 cancels, L by 3. So the first one is going to be L by 3, which is L by N, don't you think? That's what we are looking at here. See, L by N, N value is 3 here. So L by 3, this is what you are going to get. Likewise, 2L by N, 3L by N, so on and so forth it goes. So the position of the nodes in a string is given by this particular formula. Suppose if you have to calculate the position of the antinodes, the same sort of logic we are going to use. The antinodes are in between two nodes, isn't it? Since they are in between two nodes, I can easily calculate whatever is the value. Because you know the position of the nodes, divide that by 2, that's all. So you are going to have x is equal to L by 2n, 3L by 2n, 5L by 2n, so on and so forth till 2n minus 1 into L divided by 2n. These are the position of the antinodes. Like in the sense, if you take this wave, say this is 1, and say you are going to take another wave in the opposite direction, see like this. See in this one, the position of the node, this is 1, which is 0. And this one is going to be L divided by 3. This is going to be 2L by 3. And the last one is going to be L. These are the positions of the nodes. This is for the node. Now, how many antinodes are there? There are 3 antinodes, isn't it? So, this is the first antinode A. Now, when you talk about the position of the antinode, it's going to be the average of 0 and L by 3, isn't it? If you apply that the same thing in this formula, L divided by 2 into 3, which is L by 6. Or in other words, in this case, it's going to be the first one is going to be L divided by 6. The second one, it's going to be 3L divided by 6. Or in other words, you can take it as L divided by 2. 3L by 6, correct? The next one is going to be 5L divided by 6. 5L divided by 6. These are the positions of nodes and antinodes in a standing wave. Every time we pluck a string or something like this, nodes and antinodes, the distance between them is calculated. Based on that, we are going to have different types of sounds. Okay, for guitar, violin, sitar, there are so many instruments. For all of the string instruments, the position of the nodes and antinodes are very important. And that is, those instruments are designed taking the position of nodes and antinodes. And the formula is given by whatever we just derived.